and derive window to viewport transformation. Okay, so what is window? Window is part of world coordinates selected to display is window. Okay, so I don't need to write that, right? And now we are gonna talk about viewport. So it is an area of of a display device where window is mapped, right? So now we have to derive it. Now how to derive it? So what I would do is, so let's say this is your yo, what's up? One person getting your stream. Welcome to the stream, bro. Yo, what's up? Come on the chats, bro. Come on the chats. What's up, bro? So what I'm gonna do is, this is your let's say world, okay, part of the world, like how artists like create they see some scenes and recreate it in real life. So that part of the world, this is it, okay. So what I'm gonna do is, this is that part of the world. Now what we consider this is, let's say this is window, okay. So this is your x. Yo, what's up? What's up? Welcome to the stream, bro. What's up? Welcome to the stream. So this is your XW mean, okay. So and this is your wait a second, XW max, okay. Yo, what's up? Foreign people on the stream. Welcome to the stream, bro. Thanks for joining. Really appreciate it. So this is your YW. Yo, what's up? 15 people in the stream. Come on the chat section, bro. We can yap and interact, bro. So let's say this is YW max and this is YW min. Okay. So what is I'm talking about is, so this is let's say you're part of the world which you want to create picture of or image of. So what I'm gonna do is here. So this is y-axis. So this is y max, or the maximum of the part you want to draw. This is minimum of that y, because this is downside, this is upside, maximum, minimum, and it is east. So it is xw min, x-axis min, minimum, and this is xw max. Like after this, obviously it can't go. So the part of this is your let's say some part of it. World is a huge thing, okay. Eyes can see a bigger picture, but on my computer screen, let's say this is your computer screen, I can only add like a very tiny version of it, because my computer screen is small. So what I would do, I'm just reducing that image, okay. Let's say I'm squeezing that image, okay. I'm squeezing that image to fit in my computer screen, right? So now what happens is, this is, let's say this is view, this is window, okay. This is world coordinates or window, and this is your viewport, okay, like your computer screen. What did I say? Viewport means, yo, like, thanks for the like, bro, really appreciate it. So what did I say? Viewport is an area of display device, let's say computer, phone, whatever, where window is mapped, okay. And window is a part of the world coordinates selected to display on a screen or something, okay. So this is your window, like this is your whole thing. and this is your viewport. Okay, so let's say this is your here also we considered uppermost upper left, and this is below left, like that. So we consider those as xv x min. So like that we would consider this too. But now what we would do is, so this would be xv min. Okay, xv sorry, wait a second. This would be xv max, this would be xv min, and this would be sorry, this is yv max actually. I'm really sorry, I apologize for my mistake. So this is xv min, and this is also yv min, because y axis x axis, they obviously are because this is origin, so they are connecting here. Yo, what's up? 10 people in the stream. Come on, the chat section, bro. Come on. So this is your, bro, my marker, bro. It really doesn't work anytime. What is the problem with my markers, bro? Wait a second. Let me change my marker. Okay. So what I'm gonna do is, so this is your xv max. Okay. So this is obviously right of the x-axis, so x increases here. So what I'm gonna do is, so we are gonna take. So what we're gonna do is, so what I'm gonna do here is, I'm just gonna shift this to, to the bottom side of it, so that one side at least attaches of the viewport. Okay, to compare the sizes. Okay, because obviously it would be proportional to this. Like we are just squeezing it. Okay, squeezing it, we are making it small. Okay, so we are trying to make it small. Okay, so to fit this is a huge world which your eyes can see. We are fitting it into this. Okay, so now what I'm gonna do is, this is your wait a second, xv xv min, xv max, like that. These coordinates. Okay, yo, Sophia Galiponese says hi. Yo, hi, what's up? Nice to see you. Glad to see you. Like, nice to meet you. And really appreciate your visit. Grateful to, have your presence. Thanks for coming. Appreciate it. What's up? How's your day going? So, yeah, so this is this. Now, what I would do, we also have normalized xv and xw, yv, and yw. Okay, so now what we would do is, so for x axis we are taking it separately. Okay, xv minus xv min, okay, divided by so xv minus xv min by xv minus xv max. Then what we have here is, you have to understand that shear or scaling formula is, okay, what it is, let's say shx. Okay, it is equal to xv min minus xw max divided by xw min Oh, wait a second. XV max, bro. What I'm doing? Yes, X max comes this side, right? Oh. So what we do is XV max minus XV min divided by XW max minus XW min. So this is your so what we are doing here actually, so we are not taking the normalized one, we are like dealing with the whole window. So now what happens is, so that is how much we zoomed, okay, that is the zoomed factor, okay, how much we zoomed. So that is the zoom factor. So we have to bring this equation to this, okay. So what I'm doing here is I will tell you later on. Wait a second. So why did I tell you the shear formula first is so that even if you in your exams, if you like don't remember this, you can reverse engineer this stuff, okay, and find your derivative, like how to derive it, okay. At least you should know the formula, okay. So that would be really helpful. So let's go for it. And I would tell you like how to reverse engineer this formula too, if for some reason you forget this. But if you remember the stuff, that is obviously way better. But yeah. So what this indicates is this, or what is this, what this formula says is like this is proportionate, because proportion means what? Like this is proportionate because like this almost things are equal but they are shrunk. They are similar, they are shrunk, okay? So now what this means is ratio is equal, okay? Ratio is equal, okay? So now what this means is, now we have normalized viewport size and xw size, like we have found a middle spot of between them, okay. Now what happens is we say that this small screen or the computer screen, your viewport, is similar or proportional to the, like we have kept the measurements same but they're shrunk, okay. Like difference between them is same, like length and breadth, okay. So our world view is huge, okay. So this huge screen is similar to this tiny screen, which means xv, like this, what do we say, now we are concerned about x, okay, we only talk about one axis at a time. So now what is happening here is the viewport is proportional to so what do we say this, this is window, the, so it is proportional. Proportional means ratio is equal. So we are doing ratios now. Yeah, what's up? One person came to the stream. Welcome to the stream, bro. So what is happening here is we are finding, so this is viewport ratio xv. Yo, 2 likes. Thanks for the like, man. Really appreciate it. Thank you very much. Thank you very much. I really appreciate it. Really grateful, bro. For real. So what's happening here is xv, so this is viewport ratio and this is your window ratio, okay. So now what's happening here is this is your normalized one, normalized minus the origin stuff, like minimum stuff or the end of the screen, and this is xw, windows maximum top screen to the end, okay. So how you can reverse engineer is like we want it in this form. So how it would happen? Like if you do, it is in division. So if it comes here, then like these two get divided. Then only we will get this, right. And above this should be there, like xv should be there, normalized one should be there. So normalized minus the minimum end of the screen, and maximum minus the this minimum of the screen. So what this gives is, so this is your mean, like average of the screen. So that we are comparing with the full height, okay, full height of the screen, like from the bottom to the top. And this is mean average to the bottom, okay. So that we are dividing, that we are comparing, like how deviation is. And this we are this is same in the window, okay. So now what we would do is we cross multiply it, okay. Xv minus xv min, okay, equal to uh, xv, this comes here because this is multiplied, this is division here, right, divided comes in opposite side of equation, then it becomes multiply, okay. Opposite, because opposite of division is multiplication, right. Right. So now what would happen is xv minus xv min, oh sorry, this bottom one came up, right. So xv max minus xv min, right. Now this is xw minus xw min divided by xw max minus xw min. You got it, right. So now what is happening here is xv minus xv min. So as you know, like a fraction is a multiplication of numerators and denominators, okay. So if I multiply this to this, right, this to this, and here it is 1, so here it like these can interchange. So I can also separate this and I can divide it to this. So what is this one is xv max, like I can exchange this denominator because this is not addition, it is multiplication. So they are independently multiplying. So here it is 1, so I can multiply this to whole thing. So what would happen here is, like it can individually also divide this, right. I'm trying to say that. Now what would happen is this is xv max minus xv min, the whole screen, and this is also a viewport, and this is your whole window, which is xw xw max minus xw min. So what is this? This is actually shear, like stretching factor, how much we stretched, because this is your viewport from bottom to top, and this is your window bottom to top. So what we are doing, we actually what we did is we stretched we actually stretched this viewport into this window, right. So that's what we did. And now when we do this, this stays separate, xw minus xw min, which is your average of the screen. So why it stays? Because in shear or stretching, we actually multiply shear factor to some x-axis or y-axis, okay. So that's why it would anyway remain, like it is valid, like it is not wrong. xv minus xv min equal to, this is what this formula looks like, same stuff, so I can replace it by shear factor, shx xw xw minus xw min. So yo, what's up? One person came to the stream. Welcome to the stream, bro. What's up, bro? What's up? Welcome to the stream. Appreciate your visit. So what happens here is, so this is your like average of the screen, xw, and this is your one end of the minimum end of the screen, computer screen, okay. So this is your average half area of the screen, okay, and this is half area of your viewport. Now what I can do is I want to find the average of your viewport screen. So now what I would do is I only want that part. So what I would do, This is add. This is subtracting here. Opposite. This would turn addition on the opposite side. Now what would happen is xv min. So this is your formula, like viewport and screen plus shear factor multiplied by window, like Windows average screen to Windows last screen, like lower end. And we derived your formula. This is your actual formula, window to viewport transformation, and you are done with the question. Yeah, it was short and simple, and very few things are short and simple in this subject. So yeah, so and you can but you have to do it for y-axis too. But things would be same. Just here it would be shy, some y stuff would be here. Xv and xw would be same, only where I wrote instead of x there would be y. Okay, there would be y stuff. Okay, but everything would be solved similarly. So now what I would do is I would zoom out, because you might need to take screenshot or notes or something, and then I would take off like a rocket. Definition might be wrong, but yeah, like you can check it out later, but that's how it is actually. So thanks for watching, like, share, subscribe, and see you next time. Bye.